Yeah, so hello everyone. I hope my mic is
So,
audible. So yeah, yeah, doing cool things with Yocto at AWS IoT. Thanks for giving me the opportunity to speak here. My name is Thomas Roos. I work for AWS, and I'm telling you about what we are doing. Uh, Yeah, first a disclaimer. It's just a brief overview what we are doing to get some inspiration by showcasing, giving ideas what can be done for layer maintenance and other things. It's not a tech dive into the topics. If you have questions, I'm happy to answer all of them later on. Yeah, so I'm doing maintenance of Meta AWS since about 3 years, among other things. And 2022, I gave already a talk here, and this is an update on that talk. If you're interested in, especially in the recipe upgrade logic I've implemented, I highly recommend to watch that talk again. It's on YouTube, I'm sure. So what's the goal? Still the goal is to provide our latest software to our customers with Meta AWS. What is Meta AWS? It's AWS, Amazon SDKs, examples in C, C++, Python. It's the actual Java runtimes for Java 8, 11, 17, 21 as binary package. That is might interesting for some of you because building them from source code is um, I would not say impossible, but I heard many people complaining about that, and I'm not sure if anyone achieved it yet with recent versions. So we have tools like for the AWS CLI to do stuff in the cloud. We have Firecracker, which runs like micro VMs. For Lambda, we use them. And we have edge runtimes for IoT. It's Greengrass in Java and soon coming the C version. And it's IoT device client, Fleetwise, SSM agent. Um, One interesting thing which is included in Meta AWS is the so-called EC2 feature. It's a basic, simple class to inherit, and that will allow you to generate an image from your Yocto image, and that can be uploaded to EC2, and you can run them in cloud for testing or for production, whatever you want. So what's the problem with Meta AWS maintenance? It's like around about 50 recipes. We are supporting 4 non-end-of-life releases. We have 3 processor architectures. That means 12 builds tests for each upgrade. And manual testing is not good, as you all know. We have some packages that upgrade like daily, and if you do that all manually, that's a waste of time. Yeah, so automation is key, but do not ship broken recipes. You don't want to break things, and if you don't test, you never know if it's working. So that's the basic workflow I showed already like 2 years ago. It's upgrade, test, integrate, release, and then backport, test, integrate, release, and that for all supported releases. We achieved that. So it's like 10,000 automated pull requests since then, since 2 years. We have now p-tests for every package in our layer. The workflow is fully automated in GitHub Actions, all open source. You can look it up. You can see what we are doing. It's nothing behind the scenes. Just recently, we changed like from our self-made webhook connection setup to code build connector, which is like an easy way to set up a GitHub runner. And we have also created like an CDK app for this. Infrastructure as code, especially for Yocto builds, like state downloads live on a shared network folder and are shared between the runners. More updates. We have added some lint checking, which is great for having like similar recipe styles. And also we have that CVE check workflow. We check for CVEs in our recipes and also on pull requests. At the moment, there is some struggles. Marta said that earlier today, so we will, yeah, see what if this is working flawlessly again soon, hopefully. And also we have like a Yocto check layer GitHub workflow. So with every pull request, we checking if we are messing up something. That's like the GitHub meta-aws workflow. That's, as said, is all on GitHub. In GitHub Actions, you can take it, use it, see it as a reference. What else? We created like a meta-aws build bot. It's a setup for the build bot. Same thing as the Yocto project is running for CI. We created like a CDK app for this to set up this in like 10 minutes, again with shared estate and also with different instance types configurable, so it doesn't have to be expensive. We used it for meta AWS test image p-test checks, and we run them on an EC2 metal instance with KVM support. So it's super fast, super cool. And this is how it looks. I take this as a like the final decision if I do like a fast forward merge the next branch to the release branch to see if everything is green. Then I do a release like weekly. What else? We have meta AWS demos. It's like demo images for AWS software. But that setup I created there can be adapted to like anything with Yocto, what Yocto can build. What we are actually doing is we're building like the whole release images, the demo images for Raspberry Pi 5 and others, all in GitHub workflows, all with that setup. And that layer setup is done with the template conf and Git submodules. I like Git submodules, not CAS or repo tool. So that's my favorite. And with that setup, like matrix builds are possible, like images on X devices, which is pretty cool, I think. The intent here is to help people to get started with Yocto easily without having knowledge of Yocto yet. So I tried with some colleagues and they got their first image built from scratch in like 1 hour, which was amazing without Yocto knowledge. So it should be good for developers. Yeah, that's a CID system to build the whole images. By the way, they are taking like maximum 5 minutes if it's just compiling like a C program which is changed on that image. Each share like the same estate and downloads as used in meta AWS. So maximum reusage of resources and cache here. Okay, so 10 minutes are already gone. Next, what else? Wick is a great, that's one cool thing I did recently, like a proof of concept is like to modify, configure images in a Lambda function. That means like with a HTTP request, there is such a Lambda function started and it will use the Wick tool to make a modification in an image and provide like the download image with the personalized image via HTTP to download. I like that a lot. So since then, I like Wik a lot. What else? QEMU is good for non-hardware tests. No need for a board farm at the moment. Yeah, if you don't do hardware, what's included in Yocto, like the p-tests with test image with QEMU, are totally good. We use them a lot. Here are the links. I uploaded my slides. You can check that out later. As said, it's yeah, it was just a brief overview of some ideas, what can be done, what we did, and yeah, have a look by yourself. Any questions, I'm happy to answer them later in IRC or via email. Yeah, and now I'm handing over to Oscar. Just one final slide. I like to thank everybody that is involved in the project. I like Yocto a lot, and I think Yocto is cool, and you can do amazing things with that. So with that being said, I like to hand over to Oscar, which is working in the OSPO office of Amazon.
Thank you, Thomas. I think that I need to get the, yeah. Okay, folks, I hope this is visual and you can see the presentation that I'm providing. So I want to talk a little about what we do as the OSPO at Amazon. And most likely our focus is going to be talking about how we manage compliance for Yocto. I know that there's been like a lot of talks today, so I don't want to reinvent the wheel and cover the same things that we expect to see or that we have seen already. I'm going to talk a little about our experience. OSPO had the privileged position of like being part of every product and every project that is being built at Amazon as a whole. So we live in a centralized hub and allow us to participate in all stuff. We have seen projects that going successful to customer hands, and we are seeing testing, development, some other projects who never went out, but it still is a fun from the perspective of the different kind of use cases. We review satellite software, we review car software, we review routers and hardware consumer. And getting involved with Yocto is one of the things that we help us to learn, but also help us to improve our processes towards governance and software governance to make sure the customer get the best. I want to talk a little about me very quickly. I have a background in electronics, in 10 years in telecommunications. I moved to software later of that. I joined the Free Software Foundation in 2024, sorry, in 2024, and joined the Free Software Foundation Latin America later. Been doing a lot of work around compliance and helping other projects. I joined the meta-aws project and I participated in a bunch of other open source projects. A lot of fun. So I want to set a little of context of what we're going to do today. We're going to be talking about some of the challenges in real world cases. They're going to be very generic. I cannot go deep because of time, of course, and some additional restrictions. I want to talk about a little about how we use SBOM, what we have fun while trying to use SBOM for compliance. Had not been easy, a lot of challenges, a lot of adventures there. And I want to share a little about the best practices and learning that we have got now. Um, so challenges when we use Yocto for real world scenarios. When we build software and projects and consumer devices, there are a little of different things. And that's that you need to learn and you need to focus. And that is not because of Yocto as any other project. It's just because you're using open source. And open source in compliance and do risk assessment, it's not that easy as a white and black and one and zeros. There is a lot of nuances and things that you need to understand based on the architecture, how the user interact, how the software is being built. Um, there is a lot of cases where we see that is getting more and more complex than what we would like, mostly because challenges around the technology, the recipes, and how open source developers work. Also, there's a lot of challenges related with SAA tools and other trust from different areas on the organization, not just us, but also vendors. People who focus on security are expecting to mostly to use SAA tools, and one-click solution will not work for all the technical complexity that will come in a real-world product. Projects and open source projects or a small project that are simple like routers are more simple to do compliance than usually bigger and more complex. Um, and also how we deal with supply chain and sub vendors in cases where I would say S1 had not been able to save us in and add some complexity and problems. So we're going to talk a little about that as well. So unclear licenses for components and recipes. We know that education and training for developers is very important. It's the first layer of like that help us to understand the complexity of the software, but also understand the nuances of how we use. That's the reason why we focus on trying to teach people not how to do compliance, but understand the risks and how need to share, need to deal with different complexities around the software. It's very typical that we get requests and a question from people who is looking to use particular component, clarifying that the license for the component is MIT, for example, and that's not real. It's not a component that's gonna go out the door. It's just the recipes and the separate recipes in a GitHub project from a vendor, a hardware vendor. This is very often there happening there. Are under one license, usually MIT, but the VB files are declared a different license, so they're developers struggle to understand which is the license that apply to the use case. This increases the complexity for the cases where the software that's been built by this BB will be under multiple licenses, cases like FFmpeg or GStreamer or a bunch of other that are have their nuances. It's not very complicated. It's just you need to understand how the different things are wired to understand what are the licenses that are triggered. And we want to make sure that we fulfill the responsibilities. We want to make sure that we deliver also the best experience and security for our for customers. As such, we need to go in the technological trend that add more complexity to each use case. This is very often. It's something that happens very often. Like recipes under one license declare a different license, the BB files, and the software being built, it live under complete different license, in many cases with multiple license. So that's a very common case of where we need to deal with. This jumped really quickly. Let's go to see. Yeah, see, there's a lot of software vendors that provide SEA solutions, software composition analysis tools, expecting to provide deep understanding of the software and what is under the hood. But the reality is like not all the SEA tool will be good for one cases, will not be good for other, will be good to analyze some layers, but not others. And the challenges there are that technical complexity will mean that you are not going to be able to extract the information that you need and to insert in your pipeline of compliance. Very frequent cases that we have seen of when we work with partners or we build products is cases with encrypted raw file systems that tool declare that they support firmware scanning, but actually they don't when there's encrypted. So you need to be able to detect those challenges. Identification of bundle binaries. Some cases it comes with a bunch of things that are under the hood, not declared the top layer, not declared on the recipe, or not declared on the metadata or the package, but it's just there. And this is very frequent for when you work with SOC vendors that they provide you SDKs and examples. Multi-layer software stack. You have, again, so SCA tool will be good for one case, but not other. Tools that are good for plagiarism will work very well on code scanning, but not very well on unidentified binaries that are not official, like from a repository or something. And challenges are there. In the practical world, we spend months trying to scan and identify all these issues. This is increased when you have a supply chain model where you receive software and from vendors that share part of their testing kits or part of the drivers emulation in different layers, and not clear and not all have very good hygiene on how they maintain and keep track of the components. It's very frequent to receive software from vendors that is intended for production, but it comes with test images and binaries that honestly they don't even know what is there that is there or what it is. In some cases, we send questions and they reply, and then the solution is like, I don't know what it is, so I'm gonna remove it when I give you the next version. So it's unclear, and again, it's not a challenge of like one vendor or two. It's like mostly like an industry. If you are trying to build a real product using Yocto, you will face these issues. And if you're not, or you're not seeing it, most likely you are not going to as deep on the rabbit hole as you need. Again, vendor providing giant PDF that with license information that have no real context, um, deep dependencies, SDK and layers that don't match with the declared SBOM. That's very frequent. They provide you an SBOM, it gives you, hey, this is what is I'm providing you as a software, but it's not it doesn't match the real in or when it match it doesn't come with the correct data, and as such, while the SBOM is valid on the schema, it was produced in a valid way. um, the data is very ugly and very low quality. It's very frequent to see those cases as well. In a real world, I will want a vendor or someone, even a developer, an internal developer, to provide me an SBOM, and that will allow me to identify risks and do additional analysis based on different buckets. But in the real world, that doesn't happen, and the reason of that is because SBOM that are produced from vendors or different architectures are good as a way to transmit information, but there is no real way to verify the quality of the messages that's being stored in this one and shared with others will really work at the level that is needed for compliance. So that will add additional complexity when you want to create automation at scale. We have resolving this by implementing additional rules and screening that allow us to detect when the quality of this bomb, even when the schema is valid, the quality of this bomb is not good. That's something we want to open source probably early next year. But it's a way to screen when the quality is not good, when we do detect things that are not making any sense, when you have a JavaScript and Apache server declaring the same as bomb, but there's no package in between those. Clearly is a word in the middle that is not being considered for this one. All this experience had helped us to have some additional learnings. And basically what we do is like when we do on scale, we do use Westbomb, but we assume good intention and verify accuracy. We work with vendors and partners to make sure that they are aware of the complexity and that they're aware that we're going to be screening anything that we receive. We want to make sure that is covered for our analysis. Basic things, and we do match that the SBOM match with the artifact that we provided, and or build in even in an Amazon between the different parties and different teams. We look for that station and in assertions that have been provided with the user confirm a license, confirm the quality of the package. We verify the SBOM metadata. I've been seeing a lot of cases where people create an SBOM and then use a different tool. They try to merge the information, and the final artifact doesn't make any sense. We want to make sure that all the components have the same hash types, and the length on the hashes makes sense. So if they have it modified, they have a length that is expected. It's not difficult to implement this rule, but it's something that we tend to forget when we assume that SBOM for compliance or any analysis is good. As for Yocto itself, I think that Yocto already have really good tools and features for doing compliance and risk analysis from the open source perspective. I saw a talk early today about talking about how to use different tooling integrated on the tool chains that allow you to do most of the things that you need, like generate the compliance artifact, generate the manifest, generate automated SBOMs. There are tools already there. You just need to look and how to use and implement it in your pipeline and processes, put in the right place for screening analysis, of course. Leveraging and licensing compatibility, but that's sometimes not sufficient. What I've learned working with 90,000 developers that work on different Yocto products and other products is like you need continuous compliance monitoring. You need to understand what is happening. Sometimes preventing simple things like modification on tags, because of course, if you have license compatibility set, and is the product's not building with that layer because the license is not allowed, the user will try to attempt to modify the license to make it build. So having this prevention or way to monitor is important. And also have S1 generation for every build to understand there is delta that were detected. But again, the quality of the S1 will depend on the ACE tools and how deep you went in the rabbit hole to understand what complex components are under the hood. So some take a good ideas. S1 for compliance is making total sense for a device more than anything. It will help you to scale. It's going to help you to build a product in a pipeline that will keep your compliance in place. But remember, that is a good starting point. You will need to do other tools. Um, Attempt to use the Yocto compliance tool. There are really good ones that are being provided. And remember, it's unrealistic to think that a single SA tool will do all the complexity things when you want something to scale. You want to make sure that you go and do an additional screening. And 50 minutes gone. I know that Thomas said that we should get questions. So my contact information is in the talk description under my profile. So if you want to hit me on LinkedIn, feel free, or send me an email. Happy to answer any questions. Thank you.